Are starting lesson 4.2 today, page 225. Analyze linear associations. And so have we done linear stuff already before? Oh yeah, we've done lots of linear stuff. Functions and linear equations and linear functions and those kind of things. And associations was kind of a word they threw at us yesterday when we talked about scatter plots. When there is a positive association, it goes up from left to right. It's like a positive slope. And when there's a negative association, it goes down. So it's like a negative slope. So we have, now we're going to see kind of how those associations in a scatter plot relate to some of the stuff that we've already done with equations and things like that. So we're kind of melding the last unit together with some of the stuff that we've already learned in this unit. Okay? All right, here we go. The essential question for today, by the way, is how can you describe the association of two data sets? Well, linear and nonlinear and those kind of words are going to be big today. All right, here we go. Your warm-up. Angus, gotta love that name. Angus has a big test coming up. Should he stay up late and study, or should he go to bed early the night before the test? And defend your recommendation. It's not, by the way, you don't get to pick option 3 of staying up late and playing, Fortnite. It's either stay up late and study or go to bed early. One of those two, right? Okay. So test number 1, went to bed at 9:15, got 80%. Test number 2, studied until 10:30, got a 75%. Yikes. Test 3, studied until 11. Got a 92%. And then test 4, went to bed at 8:30, got an 89%. Test 5, studied until 10:45, got an 86%. And test 6, he went to bed at 9, got a 93%. So, what do you think, Mace?
Well, there's a study that when you study hard at night, you don't study a lot. It's just going to turn into short form memory. And you lose that memory. So when you eventually get to the test, you'll remember some things, but not a lot.
It is true that one of the best things you can do for yourself is to review, do a quick 10 to 15 minute review right before you go to bed. Make that the last thing you do. Don't do 10, 15 minute review and then lay in your bed and play on your phone for 30 minutes. But you do a 10 or 15 minute review before bedtime and really concentrate on that stuff and then lay down and go to sleep. And then your brain will focus on those things and will convert some of those things into memory as you sleep. So it is a good thing. Can you make a general statement about which option leads to a better result?
Going to bed early.
Going to bed early, it seems like going to bed early was never a bad thing, right? Staying up late and studying seemed to hurt him one time, but maybe that was just a really hard chapter too. Maybe you missed some days of school for that unit or something. There's other variables that we can throw in here, right? So it's kind of hard to make just a general, overall, broad sweeping statement about which one's better. Because sometimes staying up later, like there he stayed up, that was the latest he stayed up and he got a 92%. That's a pretty good test.
Yeah, that's good.
So it's kind of hard to make just a general, here's the rule based on what happened to old Angus here. What other factors should Angus also take into consideration to make his decision? Well, we just mentioned some of those, like how many days of school did he miss? How many units are in the chapter? How did he do on the quizzes and the assignments leading up to this test?
What time is it?
Yeah, what time is the test in the day? If the test is at first thing in the morning, he probably needs to get all his studying out of the way tonight. But if the test is not till mid-afternoon, maybe he's got time during the day. He can do some more studying. So getting that extra sleep is a good idea.
Well, if he just studies before, he goes to sleep early.
Well, maybe he had play practice. I don't know.
Wouldn't
We're
that
not.
have the best result, though?
I don't. Well, it would, but if he can, but maybe he can't. All right. So there are but those are some of those other factors he's got to take into consideration.
What time is it when he wrote this?
Yeah, what time did he? Now, if he didn't start studying until 10:15 and he studied till 11, that's a bad deal. But if he'd been studying since 6 o'clock and studied till 11:15, then that's different. All right, who knows? All right, here we go. Oh, look, a video. let's watch that and see what happens.
How can you describe the association of two data sets?
Wasn't
Think
even up
about
that
this
loud.
question during the lesson. Georgia and her classmates are measuring their height and arm span. They record their data in a table. What relationship might there be between the two measurements?
What would you predict is going to happen if you measure people's their height and their arm spans?
It's gonna be different.
It's gonna be similar.
It's okay.
No, it's gonna be it's gonna be relatively the same.
Relatively similar. So as their height increases, what would you expect their arm span to do?
Increase
Also increase. So you would expect taller people to have longer arm spans. I mean, you just expect that, right? So that's the prediction we would make. Let's see what happens. Whoops, I hit the wrong button. Sorry. My bad. Now I'm at the wrong place in the video too. So let's jump ahead a bit here.
Between the two
There we go.
measurements.
All right. Now I'll hit the right button.
Arm span might increase when height increases, but this relationship is difficult to determine from the data presented in the table. How can they figure out what relationship, if any, exists between the two sets of measurements? Georgia needs to plot the data points on a scatter plot. She makes the x-axis represent the height, and the y-axis the arm span. Then she looks at the table and sees that all the data is between 58 and 67. So Georgia makes a discontinuous scale that jumps from 0 to 56 on each axis. Now, let's plot the data points in a scatter plot. Georgia can next use a pencil to find a line that passes through the middle of the plotted points.
Okay, so first of all, one thing that we're going to really kind of focus on, and maybe one of the reasons I've been a little bit grumpy today is because I've pretty well got done grading all the tests, and
At this time, I need jazz band to head to the auditorium for pictures. Jazz band.
picture
Jazz
day.
band to the auditorium.
All right, so one of the things from this last test, when you had to graph a couple of numbers, oh my goodness, some of you have forgotten how to graph things. And it's ridiculous that in 8th grade, we are having trouble graphing things. But we need to be able to graph things reliably, and it shouldn't be that big of a deal, but evidently for some of you it is. So one of the things we have to do is make sure we graph correctly. A discontinuous graph, what does that mean when they said that? What happens here in the little bottom corner of the graph?
It breaks.
Yeah, there's a break in the numbers, okay? It doesn't make any sense to draw a graph that looks like this. You can't see it, it's not gonna show up on the recording, but it doesn't make any sense to have like 0, 0 here, and then 58 or 56 all the way out here, and 56 all the way out here, and then we're graphing things up here, and that's the only part of our graph. We've got all this graph over here that's unused. So we just chop that off. We're gonna get rid of that. And so they put that little symbol there because notice the way that the graph is numbered. The way that the graph is numbered by ones, 56, 57, 58, 59, 60 on both directions, right? Well, you can't jump from 0 all the way to 56 in that space and then have that same space be a 1 right next to it. So they have to account for that. So the graph shows the discontinuous portion there. What was the point of laying the pencil on? It kind of defines it kind of shows the shape of the graph. It kind of shows you what the graph is doing. About half the points of the graph are above the pencil, about half the points of the graph are below the pencil. the pencil follows the same slope as the general trend of the data on the graph, it's going to help us interpret the graph. That's what that does. We need to be able to do that. That's part of analyzing our graphs. Okay, so we're going to be putting lines on the graph that help us interpret the data.
This line that passes through the middle of the plotted points is called a trend line. She found a good trend line because many of the points are the same distance from the line. By drawing a trend line, how can Georgia determine the relationship between height and arm length?
It's our turn. Let's start the activity and answer that question. You can measure how good a trend line is by looking at the vertical distances between the points in the line. The total distance above the line should be about the same as the total distance below the line. The average of all the distances should be as small as possible. There's a whole formula for doing this that we're not going to get too detailed into doing right now, but in algebra books, it gets really detailed into doing this. So drag the points to find the best trend line. So George's line distance below. So if we move the line, what's happening to my
Which one is that?
numbers over there on the side?
It's going up and down.
One more call for jazz band to go to the auditorium for pictures. Jazz band to the auditorium, if you have not already gone.
Why are the words changing from below and above? Like, why are they switching places?
Well, because it depends on where the line is. If I make it the distance, distance above minus below becomes then when I make it too far that way, then you have to do the above minus the below to make it work. So I want those two numbers to be as close together as I can. So I don't want a bunch of distance like there. See how it's a bunch of distant, this number is really big and that number is small?
Yeah.
I don't like that. I want them to be as close together as possible. So one, that's pretty close. That's going to be a pretty good line for us. It's called a trend line. The thing about trend lines is if we graph the data, should our data graph look exactly the same? If that's all we've done, if we put the ordered pairs on the graph, should our graphs look exactly alike?
No. Yes.
Yes, because we have the same data. When we put the trend line on the graph, might your trend line look a little bit different than mine?
Yep.
It might look a little bit different than mine. Okay, so now are they going to be similar? Are they going to be close? Yeah, they should show the same trend in the data, but I might get my trend line just a little bit different than yours, and yours is a little bit different than mine. That's going to be okay. All right? So,
Yes.
there we go.
Look at the slope of the line. The slope is positive. Georgia can draw a trend line on the scatter plot to determine that there is a positive relationship between height and arm span. As height increases, arm span tends to increase as well. This is one way to describe the relationship between two sets of data.
That last part is way more helpful for us than that middle part where it was talking about how accurate the trend line is. The main thing that I want for us for now is that the trend line should show whether we have a positive association or a negative association or no association. Okay? Does that make sense?
Yeah.
So we just want to get a trend line on the graph that looks reasonable for where the data's at. That's what I want. Okay? All right. So Georgia and her classmates also measured their foot length. Sketch the trend line for the scatter plot. So height and foot length is what we're measuring. What would you suspect will be the case about the taller someone is? What about their foot size?
They're bigger.
Bigger.
You would expect the taller someone is, the bigger their foot size is going to be. So does this trend line fit the data?
No.
No, all of the dots are above that trend line, right? Even though it's probably close to the right shape, the right slope, it's not in the right place. And so I want my trend line to just about split the data in half and to pretty well follow the trend of the data. Now I can cut the data in half by doing this. Does that cut the data in half?
Kinda.
Yes.
Pretty well. Pretty well have half of them above and half of them below. Is it a good trend line?
Yes. No.
Does it follow the shape of the data?
No.
No, it doesn't follow the shape of the data. This one's way above the trend line, and these are way below the trend line, and I don't have very many that are close to the trend line. I want the dots to be as close to the trend line as possible. I want the most dots as close to the trend line as possible, right? And so this is, I'd call that one pretty fair. It's got about half the dots below, about half the dots above. Nothing's really way far away from the trend line, okay? Now, would somebody else maybe put their trend line more like this?
Yeah, I
Am I going to be okay with that too? Yeah, it's a little bit different than the first one was, but it's still pretty close. They're very similar. They show the same relationship. It still shows the same positive association, okay? So don't get hung up on the trend line needing to be perfect. I want it to be close. I want it to be accurate, okay? Everybody good?
Yep.
All right. The Johansons own an ice cream shop near the beach. The scatter plots show their sales by daily high temperatures. They compare their sales by daily high temperature to the number of beachgoers. Describe the association shown. So temperature, as temperature goes up, what happens to the sales of ice cream?
Goes down.
It goes down.
What?
Or up.
As temperature goes up, sales of ice cream go up. More people, the hotter it gets, the more people buy an ice cream.
Yep.
Okay? All right. What about as temperature increases, what happens to the number of people on the beach?
Oh, wait.
It's also going up, but does it go up as fast as the ice cream sales?
No.
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 Okay. So they're both positive associations, but one's going to be a steeper slope than the other, right? Okay. As the temperature increase, ice cream sales increase. The association is positive. Some of the points are far from the trend line. This shows a weak association. Did you hear those words?
Yep.
Weak association. That means that the points are far away from the trend line. Is this one going to be a weak or a strong association?
No.
Wait.
This one's going to be stronger because the points are going to be closer to the trend line. The points are grouped together in a tighter cluster, right? We learned that word yesterday, cluster. Okay, so this one, as the temperature increases, the number of beachgoers also increases. So it's also a positive association, but nearly all of the points are close to the trend line. This shows a strong association. So positive weak association, positive strong association. We don't let this one outlier here change the strength of our association. One outlier doesn't hurt us. Why might there be an outlier on a day when the temperature was high? Maybe it was raining that day. Maybe there was a lot of sharks in the water. Nobody wanted to come to the beach. All right, who knows? All right. Recognize non-linear associations. So we can have linear associations where a trend line is straight and it shows a positive association. But here, does the scatter plot show a linear or non-linear association? It's still an association. We can still tell what's going to happen. As you know, if this is like a ball that got thrown or kicked or something, as the height increases, the time goes up. That's a weird way to look at it, but whatever. That was it? That was the last one? Oh, I didn't get these dots. Okay, up here. Okay. The points in the scatter plot form a curve, so the scatter plot shows a non-linear association between the data. For each scatter plot, identify the association between the data. If there is no association, state so. So
That's association.
this is a positive linear association, right?
Yes.
Would it be a strong association or a weak association?
Kind of strong. It's kind
Pretty
of
strong. Be a pretty strong association because they're tight together. What about this one?
I don't know how you do that.
Oh, we.
Well, it would
Circle.
be non-linear. It would be kind of a circular association. I don't know what you'd call it, I guess, but it would be non-linear.
Circle
Okay.
association.
What about this one?
Weak, and how do you do that?
Well, no association. There would be no line. It's not positive, it's not negative, there's no curve. There's just no association to this data. We can't make a prediction about where the next one's going to fall. Okay, so this one has to have some kind of association because I could still make a prediction. Like if I told you you have a dot that needs to go at 4.2, well, it's either going to be somewhere here or somewhere up here. I can still make a prediction, right? So it's not linear, but there is an association. All right. All right, that gets you to your assignment. Pages, what are they?
229.
229, 230?
Yes.
Okay, so 229, 230 are your assignment, and I will we'll take it from there tomorrow.